Guys, I am now going to move to the fourth question. Okay. Before I tell you how to do this question, you need to see this ball. Now, do you agree that this ball is moving in horizontal circles? Okay. And if I increase the speed, what will happen? The ball will obviously slipped up this slope. Okay. Look at this statement of the fourth question. You can pause and read it. Okay. And I will be solving this question now. It says a car is driving around a banked road inclined at 15 degrees to the horizontal. Now the banked road is just like the inside of that ball, okay, on which the table tennis ball that was moving in horizontal circles. Okay, the car has mass 1200 kg and the radius of the circular part of the road is 60 meters. The coefficient of friction between the road and the tires is 0.75. Now if you look at this coefficient of friction thing, because the ball, it went up that inclined surface, so that would mean that in this case we shall be taking the friction down that inclined plane. And now then it says, and the car is on the point of slipping up again. So the car is on the point of slipping up the road, so that means that the frictional force is going to be down the road. So we have to find the speed of the car. Okay, now I'm going to start the solution. So guys, here is my this is the incline. This is inclined at 15 degrees. Okay, this is 15 degrees. Okay, now suppose here is the car. Okay, and the mass of the car is given as 1200. Okay, I'm writing the mass is 1200 kg, and we're given this angle as 15 degrees, and then we're given that the radius of the circular part. Now when it moves moves on this banked road, so this would be the horizontal circles would be like this. Would be, let's say here is the center, and like you see, my markers, I need to change the markers now. This would be the locus of the car. Okay, so this radius is given to us as 60 meters. Okay, and we're given that the coefficient of friction is 0.75. We shall be using this in the formula F equal to mu r. Okay, so this frictional force is downwards over here, that is our F over here. Okay, and I shall be showing R over here. This is the R, and here is the angle 15 degrees. Okay, now okay, so now as you know that we have to resolve these forces, this R and this F, parallel and perpendicular to this horizontal thing, because our car is moving in horizontal circles. Okay, so you see that this would be done like this. There has to be a right angle over here. Okay, so this, if you look at this 15 degrees, this is also going to be 15 degrees over here. Okay, I will also have to resolve this force, frictional force. Okay, and if this is 15 degrees, this is going to be 15 degrees over here. Okay, now you see that this is going to be R cos 15, and this part of this R is going to be R sine 15. Okay, similarly for this, let me try to use this red marker forcefully. This is going to be F cos, it's not working at all, so let me write this in blue then. Now this is going to be F cos 15, and this one is going to be F sine 15. Now once you have resolved all these forces, the rest is your skill on algebra, okay? So you see by looking at the components right angle to this horizontal direction, we have over here, like we have for this, like this r cos 15 and this f sine 15, and then this weight over here which is 12,000 newtons, because the mass was 1200, so I have multiplied this with 10. Okay, now this is going to give me this r cos 15, that is equal to f sine 15 plus 12,000. Now this is one of the relations, okay? And if you change your f with the mu r, so this would be, and I'm going to move this to the left hand side. So this is r cos 15 minus mu, which is 0.75 r sine 15, that is equal to 12,000. I'm taking r common from here, and this would be 12,000 divided by cos 15 minus 0.75 sine 15. You will get a value of r from here, okay? So suppose we have got that value of r, then I use this space for the horizontal part, okay? Now for the horizontal part, the forces acting towards the center, now these are the two forces. One is r sine 15, this one, and the other is f cos 15. That is the net force acting horizontally onto this car, okay? So this will be over here, this is your r sine 15 and then plus f cos 15. Now if you allow me, I can change this let me just write this, f cos 15, that is equal to ma. So this is m and v square over r. We have r as 60 meters. Here is a r, okay, 60 meters. We have this m as well. Okay guys, now the rest is quite easy. You have to use this value of r from here, okay, into this. Like this would become this r sine 15 plus mu r, this which is 0.75, and if I take r common from here, that is cos 15, that is equal to 1200 v square over 60. So using this value of r into this equation, you will be able to get the correct value of v, which is I think 27 point something meters per second. Okay, so that's it from the second case where a car was moving on a banked road and it was moving in horizontal circles. Okay, this is the diagram that I used for this, and I made this right in front of you.